So we're going to finish up exercise 3 here on Introduction to Functions, and we've already worked through parts A, B, C, and D. We decided that the equation in A, y is a function of x. In B it is not. Remember, we got that plus or minus sign in part B. That was our signal that we didn't have a function. C was a function. D was also a function. Now we're ready to work on part E. And this is going to take a little bit of algebra to get through, because what we want to do is solve for y in this equation. And what makes it a little bit challenging is that y occurs in two different positions. So in order to solve for y, we're going to have to figure out how to rewrite this with y occurring in just one position. Before we do that, though, we can clean things up a little bit. I can multiply both sides by y minus 2. It's like our LCD. That will clear the fractions. And so let's go ahead and do that. I got y minus 2. I can write it as y minus 2 over 1 times x over 1. That's the x on the left. Equals y plus 1 over y minus 2 times y minus 2 over 1. On the right-hand side, the y minus 2 cancels, and I'm left with just y plus 1. On the left-hand side, I can rewrite this with the x in front times y minus 2 in parentheses. I need those parentheses because I'm going to have to distribute the x to each of those two terms, right? I get xy minus 2x equals y plus 1. So to me, those are the cleaning up steps. Now we're ready to think about how to rewrite this with y occurring just once. What we're going to do is we're going to get any terms containing y on the same side of the equation. Here's a term containing y. Here's a term containing y. And we're also going to have to get terms that have no y on the other side of the equation. Let's just write that out. Get terms containing y on one side. Get terms with no y on the other side. And I'll show you why we're doing that in just a second and what the thinking is behind that. So I want terms containing y on the same side. So I'm going to go ahead and subtract y from both sides. And I'll write this out in detail. So the right-hand side becomes just 1. The left-hand side, xy minus 2x minus y, those are three unlike terms. They cannot be combined. But notice now, here's a term containing y. Here's a term containing y. They're on the same side of the equation. I next want to get this 2x term to the other side because I want terms with no y on the other side. This x here doesn't bother me, the x times y, because this x is part of a y term. That's fine. But this x that's in the minus 2x term has to go to the other side. So xy minus 2x minus y, I'm going to add 2x. And so I get 1 plus 2x on the other side. Minus 2x plus 2x leaves me with xy minus y on the left and 1 plus 2x on the right-hand side. Now I'm feeling good about the fact that I have these terms containing y on one side of the equation and terms without any y's on the other side. The reason I like this form is I can now apply one of the kind of most powerful tools in algebra, and you probably take it for granted, but what we can do is we can actually factor out a y from this left-hand side. factor out a common factor of y times x minus 1 in parentheses equals 1 plus 2x. So factor out y. And what the magic of that is, we took this formula where we had y occurring in two different positions. Now y occurs in just one position. So we're almost there for solving for y. We just need to divide both sides by x minus 1. And that will isolate the y, because the x minus 1 cancels there. And we have y is equal to 1 plus 2x over x minus 1. You know, it's fine just the way it is, but I'm going to rewrite that numerator because addition can be written in either order. I'll write it as y equals 2x plus 1 over x minus 1. We now have y solved for. So that's a pretty amazing little feat we just went through to get from where we started through this manipulation to get y equals an expression in x. Now there's no plus or minus sign here. In fact, we can see that if we plug in a value for x, that's going to determine a value of y, or in words we could say each value of x corresponds to just one value of y. Like there's no obvious way we're getting two different values of y for the same x here. So the conclusion is y is a function of x. And we finished part E. So back on our handout, I can go ahead and I'll circle E. That's also a function. So, okay, we're gonna, I guess I can't get the whole thing up there at the end. Sliding up and down. And we're going to continue in another video.